All right, kids, my voice is still with me, so I'm going to try to get these ones done as well. This is the Algebra 2 Common Core. For those of you complaining that it's taking me forever to get these, I apologize. I'm recovering from the flu. Seems like I've had it for about 3 weeks. Missed actually a couple days of school, which was bad. Never missed school. But anyway, my name is Mr. Krause. For the next hour or so, you can call me Mr. Key. Hopefully you saw part 1 through 12, and hopefully you did okay. This is part 1. 13 through 24. Let's see how you did. Now, this is an instructional video, so I'm going to try to show you the right way to do the problem, the right way to think about doing the problem, and then maybe some other alternatives of some other techniques you can use to solve these. If you haven't tried these problems on your own, let me say that one more time. If you have not tried these problems on your own, please don't come here to cheat. You might as well just drop the course. You're not going to pass the test. Stop watching me perform like a monkey and do the problems. You have got to try these on your own. I don't care if you just pause the video, try the problem, completely F it up, and then go watch the video and be like, oh, that's how you do it. That's cool. Give yourself an opportunity to try the problems. By F it up, I mean fun it up. Because we know the only F word you're allowed to use in my class is fun on factoring. And fractions. Oh my God, we got lots of F words in my class. Anyway, please do that. Please do that, okay? We're going to be doing 13 through 24, and let's see how you did. I got to get down to it, so let's see if I can find it. Almost there. There we go. Oh, we're going to start with this ridiculous problem. Where the hell did I go? Oh, man. Oh, wow, that was crazy. Where did... All right, sorry. I'm getting there. There it is. All right, I did not like this question. I did not like this, Sam, I am. So the question... Am I still recording? Can you still hear me? Can you hear me now? Okay, so the question says, here is the data for a postage stamp, the price of a postage stamp from over 100-year span. And if you drew this, you get this. Now, because of these over here, and because of the way I had to draw this, this would have exponential growth because of the way I drew it. Now, I don't like the question in particular because other than these 2 points or all of this in here, really, we didn't change the price for 40 years. Okay, I get it. We didn't change the price for 40 years. But then we've had a steady linear relationship. So you might have decided it was linear. It is not. It is not. And that's because of the original problems here. So it's kind of a tricky question. Thank you, New York State. So we really want exponential. If anybody picks sine, I don't even know what to tell you because it doesn't look like this. I mean, really? Does it look like a sine curve? I don't think so, kids. So it had to be exponential growth. Now, this one says we're going to start at $1.04 or 1.04 cents, 1.04 cents. This one says we're going to start at 1.43 cents. This one says we're going to have 1.4% growth, 140% growth. This one says we're going to have about, 43% growth. This one says we're going to have 4% growth. 43% growth is much higher and much steeper than this one. So if you were to graph these on your calculator, and I'm not going to take the time to do so, but if you were to graph these on your calculator and you graph number 2, it would look like this. Really steep. If you were to take the other one, it would graph like this. Now, what I don't like about it is you'll notice that because it's exponential, it's going to keep going like this, whereas this data appears to do this. But again, we don't look at this. That would be extrapolation. We're not going to look at that. So the answer in this case was choice 3. And you had to look at your graph, and you had to know it was exponential. All right, moving on. 14. The 8th and 10th term of a sequence, didn't tell you geometric or arithmetic, is 64 and 100. If the sequence is either arithmetic or geometric, the 9th term cannot be. Ooh, okay. Let's see. So let's take arithmetic because that's the easiest one. 8th and 10th term. This is 64, and this is 100. Now, the difference between these two is 36. So if I add 18, what would that be? 82? 82, and add 18, that would give me 100. So yes, 82 can be a number. So that's not it, because we're looking for, again, New York State likes to say not the answer. Now, it appears as if the answer might be 80, but I'm not really sure. So that might be a good guess, but who knows? Let's talk about geometric sequence. Now, in order for it to be a geometric sequence, I have to be able to take 64. I have to be able to multiply it by something. I shouldn't do that. I have to be able to multiply it. Whoa, shouldn't do that either. Multiply it by something to get 100. I got to... Wait. No, that's not what I want. I want to multiply it by something to get, let's say, 80. Let's say I think 80 is the answer. I can't do that. Let's say I think 80 is the answer. So I want to multiply something, 64 times something, and see if I can get 80, and then take 80 and see if I can multiply, because I think the answer is 80. So then I can take 80 and multiply by something to get 100. So let's see what do I have to multiply 64 by to get 80? Okay, divide by 64, divide by 64. Now if you reduce that, let's see, x 10 over 8, 5/4. So you get 5 over 4. So that means my geometric ratio would be 5/4. So if I take 64, and I'm going to use my calculator for this. If I take 64, oops, too much mess. If I take 64 and I multiply it by 5/4, I know I put that in there wrong. Let me go change that. So if I take 64 and multiply by 5/4, I should get 80. And then if I take that and multiply it by 5/4, I'm probably, I don't know, this looks like it could be 100. Oh, it's 100. So that is that could be my number in a geometric sequence. Multiply by 5/4. Multiply by 5/4. Well, that means negative 80 is probably good too, because if I just change this to negative 5 over 4, right? If I just change this to negative 5 over 4, I get negative 80. And then if I take negative 80 and multiply it by negative 5, shoot, don't want to do it that way. Control division. Negative 5 divided by 4, I get positive 100. So I can do negative 80 as well, so that's not it. So the answer is negative 82. You can't get negative 82. Tough question. Good question, but tough question. This question, when I first saw it, I go, oh my God, perseverance. But it's going to take me a while to read through it, so let me stop for a second. When I'm about to read a 4-sentence question in math, I rely on the wonderful Dunkin' Donuts to get me through it. Oh my God, nailed another commercial. My commercials for Dunkin' Donuts are the sickest ever. They're the best. I know that's what you're thinking. Why isn't he making millions? All right, perseverance, kids. It's got like 50 words in there and some freaking convoluted, crazy-looking, psychotic-looking equation. Ah! The loudness, the loudness of sound is measured by a unit called decibels, dBs. These are measured by first assigning the intensity, I sub 0. Let's see, we probably need that. To a very soft sound that can be called the threshold. Wait, by first assigning the intensity I0 to a very soft sound called the threshold sound. So it looks like I sub 0 is the threshold sound. So you gotta be able to read too. The sound to be measured is assigned by intensity I and the decibel rating D. Intensity I, decibel D of the sound. Using this, what the heck? Oh my God, it's got logs. I can't do it. I get log. I don't like logs. So let's look at this. D equals 10 log base 10 of I over I0. Sorry, I just got a text from my boss. All right, here we go. So how would a sound of intensity 6.3 times 10 to the third WWB classified. So this is my intensity. Now it looks like we're going to start with our threshold sound to be this. So this question is really, can you figure out what the heck they're asking for? So we want to figure out what the decibels are. Our goal is to figure out what decibels are. And they gave us everything. They gave us okay, so D is equal to 10 log. They're giving us an intensity. This is my intensity. 6.3 times 10 to the negative 3. And they gave us a threshold sound, which was my I0 of 1.0 times 10 to the negative 12. All you had to do is type it into your calculator. That's it. It's a whole freaking problem, and all I got to do is type it into my calculator? You got to be kidding me. Math can't be that easy. So 10 times the log. Now, again, it was base 10, so I don't have to put anything there. Control division. Now, here's where the tricky part comes. 6.3 times 10 to the negative 3. So 6.3 times 10 raised to the negative 3 all over. 1.0. You didn't have to put the 0.0 there. Times 10 raised to the negative 12. That's all I had to put in. I press enter. I get 97.99. This is 97.99. Guess what? That's very loud. Like me. You should have known that was going to be the answer. So, perseverance. Get through some crap to plug into your calculator. That's it. Do you have the wherewithal and the work ethic to get through problems that, more words. I hate words. All these doggone words. Pedro and Bobby each set up in their own ant farm. Pedro starts with 100 ants. And he says his ant farm is growing exponentially at a rate of 15% per month. 15% per month. Bobby starts with 350 ants and is steadily decreasing by 5 ants. Not 5%, 5 ants. So let's see if we can write these equations. Let's go Pedro. Pedro starts with 100, and he says it's growing by, he starts with 100, and it's growing by 15%. So if I want exponential growth, then I need 1.15. Now this 1.5, this is the 15% right here. All right, growth has to be bigger than 1. Decay, less than 1. Growth, bigger than 1. So that's Pedro. Let's talk about Bobby. Let's do Bobby. Bobby starts with 350 ants. And, he's not growth. He's just losing 5 ants per month. I don't know, maybe not 5x. So 350 minus 5x. Assuming both boys are accurate describing the population of farms, how many months will both have approximately the same number of ants? All right. Well, let's do it. All I got to do is plug things in and see which. So the hard part was coming up with those equations. Now I got to use I can do it 2 ways. I'm just going to stow numbers. I'm going to try 7. Let's see what 7 does. So 7, control var x. Now we'll do Pedro. Pedro is 100, parenthesis, 1.15, parenthesis, raised to the x. There's Pedro. And let's do 350 minus 5x, 315. Not too close. Let's try 8. 8, not bad though. Control var x. Enter. Let's do Pedro. Pedro's got 305. 310. That's pretty close. That's really close. What's the next one? 13. Oh, this one's going to be way off. 13. This has to be way off. So it did say approximately, right? 615, and clearly this one's going to be way lower. Okay, so obviously the answer is 8. The answer is 8 months. Now, how could I have done that another way? I could have just done this. I could have said 1, 2, 3, 4, 5, 6, 7, 8, and do Pedro and Bobby. And I can say, okay, I just got to keep multiplying by 1.15. So for Pedro, The easiest way to do that is to say, okay, take 100 and then enter it, and then to take multiply by 1.15. After 1 month, I have 115. 2, 3, 4, 7, 8, 9. Just keep going. Obviously, you can't go past 351 because Bobby started with 351, so it looks like that would be it. And then if you take Bobby, he's losing 5x. And you could have done it this way as well. The answer is 8. All right, let's move on. All right. One of my favorite kind of questions is this one. First of all, if you missed this question, shame on you, because quite frankly, this problem is so easy to do using your calculator, I don't even know what to tell you. But let's not use our calculator. Let's do it this way. So how do we do it not using our calculator? Well, first and foremost, that's backwards. So because that's backwards, I'm going to turn it around. And I'm going to make it negative x minus 4. So I'm just going to turn it around. But that negative and that negative, these two negatives right here, this one and this one, make a positive. So I'm going to turn that into positive. Oh, I can do that? Yeah. So now I got to figure out what my common denominator is. Well, if I factor this, guess what it is? X minus 4, x plus 3. By the way, I probably wouldn't have done it this way. In fact, when I made my answer key, I didn't. No, actually, that's not true. I did. I don't go through all of this work. This would be 3, x minus 4. And this one's x minus 4, x plus 3. So this one is missing an x minus 4. So I get 2 times x minus 4. This one's missing an x plus 3. So 3x plus 3. And this one's not missing anything. It's just 2x minus 2. So now I don't need these anymore. And I get 2x minus 8 plus 3x plus 9 equals 2x minus 2. Or this is 5x plus 1 equals 2x minus 2. I subtract 2, I get 3x equals, subtract 1, negative 3, and I get x equals negative 1. Boom. There's the right. Now that's the right way to do the problem. If that was a part 2 question or a part 3 question, that's how you had to do the problem. The fact of the matter is, I could have just stored 1 in for x, typed in this side, typed in this side, and guess what? They're the same number. All right, in 2013, this is a very easy question. Approximately 1.6 million kids. Oh, it is an easy question, but it's not an easy question because I forgot they changed the formula sheet. The mean score was the mean score, modal score, and standard deviation. So this is the mean. Modal just means the most frequent, and there's the standard deviation. Which score represents a 95% confidence interval or critical reading score? So what we want with this is 95. We got to say that's plus or minus 2 standard deviations. So what we do is we take the 496 and we plus or minus. So it's always the mean, right? If you go back to your standard normal curve, right? Isn't this normal? Well, the SATs are definitely normal distribution. So there's your mean score and plus or minus 2 standard deviations. So I got to add 2 of these. Well, 2 of those would be 230. And that's all there was to that problem. Plus or minus 2 standard deviations. All right, New York State. You and your nots and your untruths and your falses. Enough of this crap. Read the question, kids. Which one is not true? All right, so let's take a look. F of x is a sine function from negative pi to pi. I don't really care what it looks like. Well, yeah, it's just going to be this. From negative pi to pi. Something like this. Whatever. Log base 2. This one. It's going to look like this. Now, you got to be careful. Log base 2, it's not going to hit the y-axis because it looks like this. Now, if you don't know this, you can take the time to graph this on your graphing calculator. 3 I'm going to do down here. It's got a root at positive 0.5. It's got a root at negative 4. And it's got a root at positive 2. So it's going to look something like, oops. It's going to look something like this. You know, could look like that. It could look like something else, but something like that. And this is a absolute value, who's centered at -2, +3, -2, +2, +3, and it's coming down. Okay, now let's answer the questions. You've taken the time to put these all on your graphing calculator. Now let's answer the question. Oh, by the way, this is F, this is H, this is G, and this is J. F and J have a maximum y value of 3. That has a maximum y value of 3, and since this one has an amplitude of 3, yes. F, H, and J. So F, H, and J, these three up here, these three over here, have one y-intercept. One y-intercept. This one never hits the y-axis, and this has one y-intercept. So I think that's our answer. Let's just check. G and J, these two at the bottom, have the same n behavior as n approaches. Well, notice that this is positive, right? So that means as x goes to -infinity, so is y. So yeah, this one's going down and this one's going down. Notice it's got the same n behavior, only to the left. So that's true. G, H, and J have rational zeros. Well, let's see. G has rational zeros. I know that one. H, it goes through 0, 1. You have to remember that. That's got a rational 0. And J has a rational 0, yes. So, yeah, that's it. Choice 2 is the answer. All right, so if x plus 4 gives us a remainder of 0, that means this is a factor. If this is a factor, that means if I take this thing, this huge thing right here, and I come down here and I'm going to factor it, it's going to have 4 factors because it's a fourth polynomial. One of them is going to be x plus 4. Now, I'm not sure what these are. I have no idea, but one of them is going to be x plus 4. Well, if that's a factor, because it's got a remainder of 0, that means that x equals -4 is a 0 or a root. In other words, if I plug in -4, I get 0 out, and that's what that is right there. Not x minus 4 is a factor, x plus 4 is a factor. No conclusion, that's just wrong. So there it is, choice 2. And quite honestly, if you graphed it, you'd see that at g at -4 equals 0. Oh, this question. This question was just a pain in the complete tuchus. Where is it? Hopefully I'm getting all these right. I haven't been checking. Yeah. All right. So this one's just a plain pain in the keister. So average rate of change is just slope. So let's do this. I'll pick the first two I'm going to do in black. 10 to 60. 10 to 60. So if I change, I don't know what the numerator is, but the denominator is 60 minus 10, which is 50. And the numerator is, God, this is what I'm talking about. This is a pain. Let me do it over here. 2591.9 minus 1172. So it's 1419. 1419.9, right? Divided by 50 equals 28.3. So 28 point, I better put 398. All right, so that's black. Next one I'll do in blue. From 19 to 69. So the denominator is still 50. And the numerator is going to go for these two, 2990 minus 1352. 1352. I get 1638. So that's bigger than that. Divided by 50, I get 32.76. Let me do the next one in red. 36 to 72, that's these two. So the denominator is just going to be 36, because 72 minus 36 is 36. 3135.8 minus 1770.8. 1365. Now you might be, oh, that's less than 1638, but I'm dividing by a smaller number too, so you got to be careful. Divided by 36, it's 37.9. And finally, the last one is between, oops, I should do this in purple, 60 and 73. So that's got a divisor of 13. So this is probably going to be the answer. And the difference between these two, so 3186 minus 2591.9 entered, divided by 13, 45.7. So this is 45.7. So this one has the higher rate of change. It's a dumb question. All that work just to find that. All right. All right, kids, we only got 3 left. Which graph represents a cosine curve? So this is important. No horizontal shift. That means it's not sliding left or right at all. Because it's cosine and it has no horizontal shift, that means it has to start with a maximum on the y-axis. So there's a maximum on the y-axis, or a minimum, a max or a min. Because it didn't shift left or right, it can't be one of these two. These two would be sine curves, or these would be cosine curves that got slits. Like, for example, if you take this whole curve here and slide it to the left, it would look like this, right? Something like this, right? Well, notice then it's got to shift to the left or right, but we said it no shift left or right, so it's got to be one of these two. It has an amplitude of 2. This has an amplitude of 2. This has an amplitude of 2. And a period of 2 pi over 3. Now this was the important part, and this is the important part. Period. Period is defined as I'll just use the word time. It's not really time. It takes to finish one full curve. One full curve. Now remember, a full curve for cosine is start at the top, finish at the top. That's one full curve. I'm not talking about all the other curves. One full curve, 2 pi over 3. So let's see. This finishes a full cosine curve. There it is. I'm gonna do it in blue highlighter. One full cosine curve in, well, a whole lot less than 2 pi over 3. So that's not the right answer. So this is the right answer. Let's just see. There it is. It finishes right here. And look, 2 pi over 3 is less than 3 pi over 3, and 3 pi over 3 is really just pi. So there's your answer right there. According to a privacy website, Android phones lose 85% of their cash value over 1.5 years. Which expression can be used to determine or to use to estimate the value of $300 of Android phones after 1.5 years? Interesting. Well, let's do this. Let's say if we're going to lose 58%, let's take 300 and multiply it by 0.58. Now, some of you are like, oh, I'll just multiply by 0.42. Yeah, whatever. I'm just doing it this way because most kids will understand this. So we take 300 and we multiply it by 0.58. And we say, okay, we're going to lose $174. So take 300 and subtract off 174. I get 126. Now, somebody could have said, you could just take 300 and multiply it by 0.42, because if I lose 58%, that means I still have 42%. And I could have just done this, 300 times 0.42, and I get 126. So what's the question asking? The question asking is, which one of these, when I put in 1.5, which one of these would give me 126? I'm looking for 126. So, a lot of kids chose this as the answer because they're like, oh my God, I see 0.58. We got to put 0.58. Guess what? I'm certain that these are not the ones. Most of the kids, they saw 0.58, or maybe they were smart enough and go 0.42. So we want to use the one to estimate the value of the phone after 120. Not how much we lost, the value of the phone. So I'm going to type in 300 times e to the negative 0.87. 125.6. I'm going to guess the other one is going to be 174. Yeah, I'm sure the other one's going to be 174. 300 times e to the negative 0.63. And there's the one. Oh, no, it's not even 174. So the answer is choice 1. This one here will have about $126 left over. Not an easy question. Not an easy question, but not bad. And here we go again. For some reason, this person wants another rate of change question. So there's this equation. It's a cubic. And we want to know over which interval is the volume of the box changing fastest, or which one has the fastest or the highest average rate of change. So I'm going to put the intervals from 1 to 2, from, that's red will be this one, from 1 to 3.5, that's that one. Let's do purple. Purple will be 1 to 5. 1 to 5. And last but not least, orange will be 0 to 3.5. Okay, so the answer is choice 1. And I'm going to tell you right now why. This part right here is pretty steep. It's always going up, and it's pretty steep. Notice what happens when I get up around here. It starts becoming less and less steep, right? So if I had to average in this over that whole time, this would be the steepest. If I had to average from here, here's got less steep stuff, here's got less steep stuff. So that's why the answer is choice 1. But let me show you how to do it so you know for certain. So this goes 9 to 0, so 9 minus 0 over 1, which is 9. This is 9. 3.5. If I did 1 to 3.5 from here to here, well, this is what? 17. So 17 minus 1, or minus 0, over 3.5. Well, that's 17 over 3.5, which is approximately 6, a little less than 6. So that's less already. So if I pick from here to here, the change in y's, well, the change in y's from here to here is 0 minus 0 over 4, so that's just 0. That certainly isn't it. And I bet most kids pick from here to here because it's the longest line. Remember, we're not looking for the longest line, we're looking for the most steep. Well, this goes from 17 minus, was that negative 7? Negative 5. All over 3.5. 3.5. So this is 22 over 3.5. And this is approximately 7. So that's why choice 1 is the answer. All done. Hit subscribe, hit like. Hopefully you crushed the multiple choice. Some were easy, some not so easy. The word of the day is perseverance. Did you get through it? All right? That's the word of the day.